adventure.
Hello and welcome to the first of a brand new series of Commodore programming videos. This will run in parallel with the other videos about the assembly language and the BBC micro assembly programming, as well as the Commodore 64 one, but this is just something a little bit different I wanted to start, and depending on how popular it is, we'll continue it. What I wanted to do was write something for the Commodore 128 native mode, either 40 or 80 columns, and I thought, well, why not write a very simple like text adventure game. So doing a bit of digging about, I thought Pascal would be the best system to use, and the version we are using supports both 40 and 80 column. In fact, you can use the same source code for both and have it detect what mode it's in and sort of react differently. But for now, we will just write it so it'll work on either in just normal slow mode. Okay, so what we're going to be using is Vice emulator. I did a little poll. I was going to look at doing it on the actual Commodore 128, but most people don't have one. And Vice is free and easy and runs on pretty much any modern computer. So without any further ado, let's look at what I'm using. Okay, so I'm using GTK Vice. I found this is the most stable version and the easiest to use. I didn't get on with the SDL, it crashed a lot, so I think we'll use the GTK. And if we look on the website, okay, we're now up to version 3.8. We need at least 3.6. So if you're running 3.5 or below, it'll be a pain for you to access 80 column mode on the Commodore 128 emulation. So make sure you get the latest version, plus all the bugs will be fixed. So as the time of this video recording, we're up to 3.8. Okay, so the links are in the description, so download and install the latest version. Okay, and hopefully you can follow this video along. Okay, so I have downloaded Vice and extracted the zip, and I've put it in my emulators folder on my D drive. This is what we get. We get a bin, a 64 folder and various other folders. We are interested in bin. So we go to bin, we scroll right down to the bottom, and if you look, there's a file called X128. If we run that, we will get the Commodore 128 emulator started up, and we'll go through a few settings. Right, here we are. This is the 128 in 40 column mode. Okay, we'll start the video in 40 column and then we will switch to 80 column. If you go to preferences and then settings and go to, I like to save settings on exit, so we don't have to keep doing this every time, and confirm on exit as well. Okay, so what we need to do is, if we look at the peripheral devices, we just need to ensure we just have a drive 8. We don't have a drive 9, that's none. So we want drive 8 only, and we want that as a 1571 drive. That is the newer version from the 1541. It was a much faster drive. It had a burst mode on it, and the 128 did support that. So this is the one we want. Okay, I'm going to do true drive emulation on here, because what we're doing doesn't take a huge amount of time, and I've not tried it without it, to be honest. And I'm going to use the drive sound emulation. I'm not going to have it particularly loud, but I want to put it on there so we know when it's writing to disk and when it's writing to the RAM disk, which I will discuss very shortly. So these are the settings you want for now. Okay. Right. Let's look at the Pascal software we're going to use. Right, the version we are using is called Super Pascal 128. Now they do a version for the 64, But to be honest, the 128 version, where it's got all that extra RAM, absolutely knocks the, well, it's head and shoulders above the 64 version. The reason being is it creates a virtual disk drive using the available RAM, the extra RAM we've got, and you can write and save and compile stuff all using that drive, which makes things so much quicker. So this is the version we're going to use. The link is in the description. Okay, we will get it. It's a D64 image when unzipped, but we are going to use it in our D71 drive. Okay, I'll also pop a link to the manual there, which is a PDF file, so that you can have a look and just see a bit more detail about what we can do, how it all works. Right, so now that's downloaded. Okay, I've got it here. There's a folder on my desktop called Pascal Text Adventure. I've downloaded that. I'm just going to extract it with my free trial of WinRAR, and you'll notice in here we've got our Super Pascal 128.d64. So that's our D64 image. So without further ado, let's get that loaded into Vice and get it set up for ourselves. So you've got your Vice window open here. Okay, so we go to File. I always go to Smart Attach. Okay, I'm going to go to my desktop. Okay, there's my Pascal Text Adventure folder. Go into the subfolder here, and here's our disk. Okay, so we do attach and load. As you can hear, the drive is accessing it. Okay, and in the emulator, we will boot this disk. It's not auto boot, so we do shift and run stop. So in Vice, that's shift and escape. Okay. That will boot it up, and then it will do a couple of handy little actions on startup, which I'll go over. Right, so the first thing is our options, what we want to set up. Okay, and I'm going to go over the options that I recommend. So we will click A, okay, which is our clock. I don't really care about the time, so all we just need to do here is S and start the clock. I doubt it's very it's usable. We're not going to really use the clock that much for what we're doing. Okay, we can change the background and character colours, do that to whatever you want. I'm quite happy with the white on blue. It's pretty readable, even though I've got the CRT emulation running on this. So I will press Q for that. Now here's an important one, okay? If you're running in 40 column mode, you need it in slow mode, otherwise you won't, the screen will blank whenever it does anything, because it's using, it turns off the VIC, which keeps the machine running at 1 megahertz. So if we're going to use 40 column mode, we are going to keep it in slow mode. If we're going to use 128, 80 column mode, then we could use fast. You can use slow on both, and you can change the actual speed inside your program if you desire it. So for this, I'm going to use S for slow. Then I'm going to quit. Now this, do you want it to beep every time you do a new line? Which you can probably hear now. Obviously, it will do our nutting. It's like Chinese water torture. So I'm going to press C, which clears the beeps. Okay, and then I'm going to hit Q. Okay, so now we've done all our options. I'm going to hit S to save. So that next time we boot into Pascal, it will load those options in, and all we have to do is hit Q. Okay, so now it's actually loading the Pascal system, but it does actually run a startup utility. And what this is doing, you can see that source drive 0 and destination drive 2. Drive 2 is our RAM drive. And what it's actually doing here, it's copying the editor and the compiler over to the RAM drive, so it'd be nice and quick for us to use. If we had two 1571 drives, we'd have drive 0 and 1 would be the drives, and 2 would still be the RAM drive. Okay, so now we are in the source editor here. To switch your drive and do a directory, you hit M, which is down here as map drive. Okay, so drive 2 is what we want. And if we look at this, Okay, you can see load dat, which is the kernel. Okay, the editor and the compiler are on this disk. Okay, and you can see C and what looks like a backwards arrow. That's the 128 equivalent, or the PETSCII equivalent of an underscore. We'll be using that a lot. You can get that on, well, I'm on my UK keyboard by doing shift and the hash key, which is shift and tilde. But you may have to experiment if you're using a different keyboard layout than the UK. Okay. Right, so we've got everything in RAM here. So the compiler's in RAM. If we quit the compiler with Q, okay, our system is here. Okay, we can, we've got certain things like the compiler and the editor. Okay, and then there's other utilities which are used for creating startup files, adding any assembly language into it, running your compiled program, copying files to and from different drives, to the RAM drive, to a physical drive, etc. But we're not going to worry about any of those. Okay, so what we do want to do is create ourselves a save disk. Yep, that's for saving our programs on once we finished editing it in the RAM drive. Okay, because the trouble with the RAM drive is once you've written your program and saved it on there, you turn off your machine or reboot it, it's lost. So we need to create a special disk for saving our files on before we quit. So what we're going to do, we're going to look at, let's have a look and see what's on this disk. This is, you'll be using the system disk drive 0. Okay, now there's a little utility here called sysgen. Okay, so we're going to run that. So we hit R to run. Okay, and our file title is sysgen. Okay, it's on drive 0 because it doesn't copy that to the RAM drive because we very, very rarely use it or need it. Okay, and this will generate as a system disk with just the kernel on it for us to save our utilities, because it doesn't save programs to the disk in the usual format that you'll see. So you won't be able to see what it looks like in normal native mode of Commodore 128. Right, so drive 0, don't worry, we're not going to overwrite our disk. This title, this is going to be our text adventure, so we'll just call it Advent. So we're going to insert a disk. Okay, right, the good thing about this Vice emulator is we can do a create and attach an empty disk image. So here we go. Well, let's put it on our desktop in our folder. Okay, in our Pascal text adventure, or wherever we're going to do that. So we're going to call this Advent. Okay, the type we want is, because we are using 1571 drive, this does need to be a D71. If you use a D64, when it tries to write it, it will fail. The only way to write a D64 disk is to have a D64 drive attached instead of a D71. But because we have a D71, that's what we're going to use. So advent.d71, and the disk name inside, we will just call that Advent as well. Okay, it's going to be attached to drive 8. Okay, and let's save that. Okay, so that's it. That's loaded into our machine. Okay, we will hit return. Are you sure? Okay, yes, we're definitely sure. Okay, now this will format the disk. It may take a minute or so. I will jump cut to when it's finished. Right, this is completed. As you can see, when it's finished, it does a directory, and all we've got is the kernel, which is load dat, which means this disk will boot on its own, but there'll just be nothing on it except the kernel. Right, okay, we can leave this disk in now because the compiler and the editor are on the RAM drive. So what we'll do is we will say no to here. Okay, and we will switch to the RAM drive by hitting M. and then selecting drive 2. So we've got the editor. Okay. So the last thing we're going to do is we're going to switch to 80 column mode. Why? Because I like it. Okay, so what we're going to do, we're going to go back here. We're going to smart attach our Super Pascal disk again, our system disk. Okay, let's restart our emulator. Let's do a hard reset. Listen to the drive clicking. It does a seek. Right, now, for versions 3.6 and above of GTK Vice, okay, if you look down here, it's quite small on my screen because it's a sort of high-res, ultra-wide. There's an 80 column button. That's the equivalent of the 4080 column button on the 128 itself. It's a trigger button like shift lock. It's an on and an off state. Okay, so what we're going to do, we're going to click this 80 column button. You see it, and it will light up green. Okay, so if you notice for here, we've got two Vice windows for 128, the 40 column output and the 80 column output. So we're going to switch to this one, 80 column output. As you can see, it's blank because after we pressed it, we need to reset the machine in order for this to work. So what we'll do is we will just go reset, hard reset. Now because this is set to 80 column mode, it will boot straight into 80 column mode. Okay, we still get something on the 40 column display, but it's not the active display. Right, let's shift and run stop or escape. We're going to boot up into Super Pascal again. When you get to this, because our settings are already saved on the disk, we just hit Q and let it copy everything over to the RAM disk. Okay, so it's booted us straight into the editor on the RAM disk. We can verify that by hitting M, and it's on drive 2. We can see we've got the editor and the compiler. Okay, so the last thing we need to do is just smart attach our save disk, because we're not going to be doing anything apart from compiling and editing now. Okay, so we will stick with the RAM disk for now. Right, let's crack on and get our first bit of code in. So what we will do just a simple hello world, okay, just to look at the structure of a Pascal program on here. So we do N for numbering, which is auto numbering, and if we look, that will start us straight off at line 1000. Now let's look at the structure of what we're going to do. Every Pascal program has to start with a program declaration. Okay, so we're going to do program. This is the program name, and this is what it compiles it to. So we're just call it Advent. Okay, we'll terminate with a semicolon here, and if we hit enter, it will go straight onto the next line. Okay, so now what's got to do is do our main. We can do our main entry point procedure, which we start with begin. Okay, there is a certain structure you've got to do when you declared your program. You normally then declare your variables, then all your subroutines, and you can name them, or functions, however you want to call them, and then finally your main routine. So we're just going to crack on with our main routine for now. So we're going to do begin. Okay, we don't need to terminate that. Okay, let's tab in with a space, and we will do write ln, which will write a line, then a bracket, then the apostrophe. We use apostrophe instead of quotes. Okay, and then this will be hello world. Okay, we'll close that there, and we'll close our brackets, we'll parentheses, and then we'll terminate that. Okay, so that's our program, and we end our final, our main entry point routine with end. and a full stop. Okay, so we hit enter there, that will go to 1020, but all we need to do now is just hit enter again, okay, and it will come out of the auto numbering. Okay, so that's our first program. We can get a listing by just hitting L. Okay, and there it is. So let's save that to our RAM disk and see if we can compile and run it. Okay, so what we do, there's two commands here for saving and loading, which is get and put. Yeah, so we're going to put this on the disk. So we hit P. We'll give it a file title. The best practice and recommendation is to do an S, and then the back arrow, which is the equivalent of an underscore. S being source. Okay, so that's hitting my hash tilde key next to the big enter key and shift, and then we'll call it Advent. And that will save it automatically onto drive 2, as you can see, which is the RAM disk. And that was instant, okay? There's no disk activity, no waiting around, which you would have got with the Commodore 64 version. Okay, so that is now saved. We can hit M and look on our drive. And you can see our RAM drive has the load back kernel, it has the editor, the compiler, and it has S Advent there. Okay, so let's compile this now. We've got to compile this down to an executable with machine code. That's what the built-in compiler will do. So we hit Q to come out of the editor. We're back in the main system. Okay, then we will go to compiler, which is C. Now what's the file title? Right, now we can type this in, or we can use a very handy feature, which is the asterisk. So we can use the asterisk key, and that will be the last file that we saved from the editor. So we hit enter there. Okay, it knows to get S Advent from drive 2. And we'll hit yes there. That will load it. Okay, default options, I always hit Y for that. Okay, now that's compiled completely, and with no errors, so it's 100% flawless. That is amazing, isn't it? Okay. So the statistical summary, I never bother with that. Okay, hit N. Okay, and that is now linked and saved into a binary called Advent. Now, if we do our directory on drive 2, okay, you can see there's a file there called Advent. Now, what do we want to do with that? Okay, well, we want to run it. So we hit R, which will run a file. This is all done from outside the editor in the main system. File title, I think we can do a star there as well, and that will run the last compiled file. And there we go, it's run it, and now it's given us the menu again. You can see here it's displayed Hello World. Amazing. Right, okay, let's go back into the editor. Okay, now what we need to do, we need to, there's nothing in memory as far as I know. See, there's nothing in memory. We need to get instead of put. So we'll do get. File title, I don't think the star works here when you go back into the editor, but we'll try it. Yeah, see, it didn't like it. So we're going to have to do get, and it's S Advent. Okay, that's loaded that in, and there is our program. Okay, so we can't really do much with it as it is, but we need to sort of restructure it a bit, because remember I said earlier, we need our variables and procedures first. Okay, before we have our main entry begin and end. So what we're going to do, we're going to use a nice little program shifting around feature we've got here. Okay, so what I'm going to do, I'm going to do N, and I'm going to start from line 1020. Okay, now I'm going to do our variables. Okay, so what I'm going to do is I'm going to do var here in the next line, I'm going to indent it because it's the part of the var block. I'm going to do a CLS because I want a character to write characters 147. Okay, which is Commodore 64Es for clear the screen. So I'm going to set CLS up as a variable, and we have to tell it our variable types here. So we do a colon, and it's an integer. Okay, there's other variable types like string or character, but what we'll do, we'll leave that for now. Okay, so let's come out of that. Now let's look at our listing. Okay, now this is never going to run. Okay, well it will run, but the var declaration should be above the begin statement. It has to be first. Okay, so what we're going to do is we're going to move this. Okay, so the way that we want to move the vars so it is above the begin is we move the begin and the end block, which is lines 1005, 1010, 1015, we move that below the var. Okay, the way we do that is we use, if you can see here, shift line. Okay, so how that works is we go S, okay, so we want to move 1005 to 1015, and then we do a colon. And then this is a little trick. We move it to line 9999, and that will just move it to the bottom of the program. Okay, the next available line, which will likely be 1030, or it will renumber the whole thing. But it moves those three lines to the lowest part of the program it can find. Okay, so if we hit that, and then we hit L, if we look, it's completely renumbered it for us. So we've got, now it is in the proper structure. We have our var, then we have our CLS, which is our integer, and then we have our entry point. Okay. So what about if we want to write something inside the entry point? Okay. Before we write hello world, we want to assign 147 to the CLS variable, and then clear the screen before we write hello world. Well, that's simple enough with our nice renumbering feature that we have on here. Okay, so if you look, the program automatically put lines in a increments of 5, which gives us some space in between, like 1015 and 1020, to do things. So for example, I want to assign CLS to 147. So I will do, and I want to do it before it writes hello world, I will do it as line 1016. Okay, because it's indented, I'll do another space, and you'll see why in a minute. And I will do CLS, because we're giving it a value here, equals 147, then terminate it with the colon. So now if we list it, okay, we can see that CLS is assigned to 147, and it assigns that before it writes hello world. Okay, so let's clear the screen as well. So what we do is we do 1017, and we want to just write, we can use the write command, and we open the brackets, and we do CHR, which is the same as this in BASIC. We do CHR, and we'll do CLS. Close the brackets for the CLS, and we'll close that bracket there, and then we'll do our semicolon. Okay, and what I need to do is go back here, because it should be indented. By 1, I'm going to hit the insert. Oh. There we go, I hit insert and then enter. So let's look at our listing now. There, so it declares our integer as CLS, assigns it the value of 147. So all we have to do to clear the screen is write CHR CLS. Okay, now say we wanted to add quite a lot more lines in between 1015 and 1020. I mean, we're starting to run out here, aren't we? Because we've only got 18 and 19 left. We've got 2 left. So what we do is we use another very powerful little feature called renumbering. So we do R, and then you'll see nothing, but if we list it again, it renumbers it all in increments of 5 again. Okay, so now our last line is 1035 instead of 1025. So we've got a lot more room to insert lines in. Okay, right, shall we see if this works? So what we do is we'll put it, we'll hit star, because it knows what file we loaded. Hit yes. Okay, we will quit out of this. Okay, then we will load the compiler, which is on C. We hit the asterisk there again, and we can confirm that. Okay, default options yes, and it's complete. I'll show you what the statistical summary looks like. It's that. Okay, so boring. So that's linked and saved it. Okay, so now we're going to run it. Hit the asterisk. There we go. It clears the screen for us. Excellent. Okay, let's go back into the editor and add something else. Okay, we're in the editor. We will do get, and we'll have to type this in. Just do a list to make sure. Okay, so let us now, let's add a feature where you've got to press any key to continue. Okay, so what we're going to need is we're going to need a car variable, okay, to store this, because a car is not a string. A car is just one ASCII character, just one, and when it's a key press, that's all we're going to need. Okay, so we need to insert a line after this, after the CLS integer. So we'll do it as 1011, and we indent it, and it'll be, we'll just call it C for now. Okay. So if we list that, okay, we've got our character called C. So we're gonna add some more lines after it writes "Hello World." Okay, let's I'll tell you what we'll do. Let's add a new line, which is characters 13. Let's add that into our variables, because I like assigning these character codes to variables because it makes them easy to remember. Okay, so we've got we've got CLS and car. So let's just do, because we don't have to group all the integers together. We can just do 1012, and we'll do NL for new line, and that is a integer. Okay, so we got CLS and C and car, and CLS, C and NL is our new line. Let's assign that to characters 13. So we're going to do it after this, because we're assigning it that there. So 1021 NL equals 13. Okay. So let's list that, and let's give it a renumber and list it. So we've given ourselves more wiggle room here to add some more stuff. So we want to write a new line after "Hello World." Okay, so let's start to let's auto number 1050, because we can put the end statement back in when we've finished. Okay, N 1050. Okay, so what we're going to do is, we're not writing a line because we've got nothing to write, and it doesn't write blank lines. We're going to just do write, which will write a character one. Well, it will write a string or character, but it won't do a new line. So we're going to write CHRNL. That's all we do there. So that's our new line. Notice the next line's auto indented it for us. And we're going to do write line. Press any key to quit. Terminate that. Okay, now in BASIC you use the get feature to get a character. We're going to use something called get key in Pascal. Oh dear, look. Okay, so we're going to assign that to C. Equals get key. Okay, basically that will do the same as the get character, but it will actually wait for a key press rather than us have to, in BASIC, we have to keep testing it, whether it's empty or blank, and then repeating in the loop. This will do all that for us. Okay, so the last one is, we'll do 1070, and that's end. We'll put our end in, so if we give that a list. Okay, so it's declaring 3 empty variables, one's an integer, no, 2 of them are integers, one's a character. Starts our program, it assigns the variable called CLS to 147 and a new line to 13. It writes the clear screen character. It then writes hello world as a line. It then writes the new line, and then it writes press any key to quit. Then it waits for a key to be pressed, and then it finishes. That should we run that? Okay, so we will put it, and you can get quite quick at this. Okay, and quit, and compile, asterisk again. 4 options, yes. Oh, okay, it's found us a problem. So the good thing about this is there's an issue on line 125. Okay. Bad thing is it's you need to look up all these error codes. Then it's not obvious. Like BASIC tells you what the error is. This you've got to look up the codes. I mean, that's why I provided the manual. I mean, they're the same across most Pascal versions across different systems. So let's hit escape. Okay, and that takes us straight into the source editor, which is really handy. So we do the list. Let's see if we can find what our problem is. Okay, it's very simple. We forgot to terminate this variable declaration with a semicolon. Simple as that. Okay, so let's do our very quick way of putting it and compiling it. Oh, and look, we've got another error, and I can see straight away what it is there. We haven't terminated the outer bracket. So we've terminated the bracket for CHR but we haven't terminated the bracket for write. So look, let's hit escape. I'll show you how quick it is to fix this. Okay, put. So you can get pretty quick at this. Finally, okay, so this is done. We won't bother with the statistical summary. Okay, so that's compiled it and saved it. Okay, so now what we want to do is we want to run the program just to test it. So hit R and then start. Hello world. Press any key to quit, and there we go. Right, let's go back into the editor, and we'll look at doing some more inputting. Let's see if we can input a string. I'll load that, and we'll get it. Okay, there's our program. Okay, so let's look at what we can do here. So let's change this to a write, because we want to do it like an input statement in BASIC. We will do, what is your And then we'll just insert one more there. Okay. So that is going to write, but not do a new line. Okay, so because we want to be able to type the name in just to the right of this. So let's get rid of line 1040 because we don't need to write a new line there. Okay, and we will get rid of 1050. We'll keep the quit stuff in there. So let's look how that looks now. Okay, so what we want to do is we want to go. We want to read the name into a variable. So first we've got to insert a variable. So we'll do that in line 1006. Okay, and the variable will be called name. And we'll make that a string variable because it's going to have more than one character in it. Okay, so we look there, we've now got 4 variables. Okay, so now we've written on the screen, what is your name? We will do 1046. Okay, what we want to do there is we want to read in the string. So R-E-A-D-L-N, it reads the line. Okay, and then into name. Simple as that. Okay, because it will wait, read line, it means it will wait until we hit the enter key before it reads it in. So now what we will do is 1047, we will print on the screen, which is right line, and we want to say hello to our person. Now we know who it is. We do hello. Then a space, and then this is how we concatenate them. We do comma name, comma, then an exclamation mark. Can you see how I've done that there? So I've written hello, comma, and a space. And you know that's inside because it's inside the apostrophe instead of quotes. Then I'm writing name, and then I'm writing some more text, which is an exclamation mark. Okay, let's list that. Okay, we'll renumber it because I was getting close to running out of space in between. Okay, and then it will ask us to quit. Right, should we compile that and run that and see how that works? Right, we'll put it. Okay, we'll quit. We will compile. Asterisk. Default options. And that's actually run nicely for us. Or compiled nicely. Let's run it. So, what is your name? JimJim. Hello, JimJim. Now, if you look at that, now we've got an issue there, haven't we? Okay. Because the enter was part of the read line, it didn't actually write the new line on the screen. Okay, so therefore, it's overwritten our prompt. So how do we get around that? Yeah, we just need to write a new line character before it actually says hello to us. So that's easy enough to do. So all we do is load the editor. Okay, we'll get our file. There it is. So we want to write it in between line 1050 and line 1055. So we'll do 1051. Write CHRNL like we did before. So that's just going to write a new line character to the screen. We'll renumber it. Okay, let's save, compile and run. Oops. Oh, that's how do I come out of that? I actually I didn't do the default options. Well, it's compiled it, but I'm going to recompile it. Okay. So let's do it again. Default options, yes. I haven't looked at the advanced stuff you can do in there. We don't want statistical summary. That's linked to it. Let's run it. What is your name? There we go. That's much more like it. Okay. It doesn't do our. We cleared out the clear screen and everything, but that's going to lead on to what we're going to do next. Okay. So imagine this is our adventure game. Well, let's come out of this and go back into the editor. Okay, we'll get the file. So, imagining this is our adventure game, I want to put a procedure in that will display the intro text. Okay. Now, I don't want to make it all as part of this main procedure. I want it to do its own procedure, because we don't really do go-to and stuff in Pascal or any sort of newer languages. We actually execute procedures, subroutines, functions, that sort of thing. Okay, so I want to create a function or procedure. I'm going to call it an intro text. It's got to go before begin, okay? Because the way Pascal interprets everything, it starts at the top. It knows about the variables. Okay, so that's when we use them in there, it already knows about them. So it needs to know about our procedure before we can call it from here. So we've got to insert it in here. So I'm going to do our usual trick that we did before. I'm going to write it at the end and then move everything, move the whole begin stuff and the main procedure underneath it. Okay, so we'll do an auto for 1080. Okay, so to do a procedure, we declare it. Procedure, we'll call it intro text. Oop, intro text. Okay, that has its own begin and end. Okay. So what we will do is we will clear the screen and write a little intro. Okay, so we're going to do write line. Okay, and we're going to concatenate all this. Or write ln. Character CLS. And the reason we know what CLS is because the time the program calls it from here, it's already assigned 147 to CLS, so it will know what it is. Okay, so it's going to write character CLS, comma, welcome to the wonderful text adventure. Okay, so that's in our quotes. Well, I say quotes and apostrophe, and then we're going to put a blank line in after that. Okay, we'll terminate all the brackets and put a semicolon in, and then we'll what will we do? That's my author comment, and we'll do another new line. Okay, and then we'll do one more. Press any key to start. And yeah, folks, you've got it right. We're going to do the same thing we did for the end. We're going to do assign C to get key. Okay, that's our intro text procedure. We end it in a similar way that we end the main entry point, but we do a semicolon here instead of a full stop. Okay, so if we, oops, no, didn't want to do that. 1115. So let's list it. Okay, so our procedure is in entirely the wrong place here. So let's shift from line 10030 down to 1075. We'll shift that down to our 999. So that's we do S 1030 to 1075, and we do the colon to 9999, and we list it again. And if we look at that, it's all looking as it should. There's our program declaration, there's our variables, there's our procedure, which is intro text, then this is our main procedure. Now, if I save this, okay, and run it, oh, I've already found a mistake there. But if you can see when it's compiling, it actually shows you the individual procedures. So error 13, let's have a look. Yes, I've got an extra bracket there. I didn't need that at all. So we'll go straight back in. Okay. And we will just take that bracket off, because we didn't have anything else in there. Let's just redo that. There we go. So that's our program. That's our intro text procedure. It chops it up there. You only get the first 8 characters, but it doesn't affect it in the program. And then our main entry point, which is there. Okay, so we won't do the statistics. We'll run it. Okay. Now, if you notice, it doesn't do anything. And the reason is because we haven't called it. So that's the last thing we need to do here, really. Okay, so let's go back to our editor. Okay, we'll get it. Okay, list it. So although we've declared it, we're not actually calling it at any point, are we? So basically what I want to do, I want to call it after we've assigned our variables here, 1070 and 1075. So let's do it at 1076, and we simply call it by typing intro text. Because we're not passing it any values, we're just running it as a procedure instead of a function. A function will return something, it would pass it a value or values, it would do something with them and return the value back to us. But this is just a standard procedure. Okay, so we're going to call that with intro text. I'm going to renumber it. Okay, and we list it again. So yeah, it assigns our variables there, then it calls intro text, and then it starts the main stuff, what is your name, and then we get the quit. So let's save that. Okay, we'll quit that. Okay, now we'll compile it. Default options, and it's done. Okay, we'll run it. Okay, so we got welcome to this wonderful text adventure. Press any key to start. What is your name? Press any key to quit. So it does everything. That's exactly what we want. Right, the last thing we're going to do on this video, because this is mainly a sort of setup and introduction video, we're going to crack on with the actual text adventure itself in the next one. What we're going to do now is we want to save this onto our actual save disk, because it's only in our RAM disk at the moment, and the reason we use it in our RAM disk, as you've seen, is how fast we can switch between compiling, saving, running, editing, etc. So the simplest way to do it, I will just go into the editor. Okay, I will load it with the get s advent. Okay, make sure it's there. Okay, and then we can make sure our save disk is in. Okay, so we will do our, if it isn't already, we'll do smart attach, choose our advent.d71. Okay, make sure that is in. Okay, we're going to switch drives using the N to drive 0. Okay, you see that's just got the load dat in there. So now we're just going to do a put again. We're going to do a P, hit an asterisk, And because we switched drives, you'll notice that it's got the S Advent, 0, so it's same to drive 0 rather than the RAM. Okay, now that is saved. So if we do an M again on drive 0 and have a look, there we go, we've got the kernel and Advent. Okay, so what if we want to? Okay, we've saved it on disk. We've turned the computer off. We've gone out and done whatever. Okay, and come back. And we want to crack on. Okay, well let's have a look at how we do that. Okay, so I'm going to hard reset the computer. Okay, now let's have a look at the disk. And we hit F3. This is what our save disk looks like. Okay, we've got Pascal and pass boot. Okay, that will boot that, load that kernel up. So we actually can't see our program here, move it. So that's why we have to use that sysgen to make ourselves Pascal save disks, which are in a completely different format and can't be read directly by the Commodore 128 BASIC. Okay, so let us put our Pascal disk in, and I'll tell you what we're going to do. We are going to switch to 40-column mode just to show you that whatever we've done works on both. So I'm going to smart attach the system disk. Okay, I've unticked 80-column down in the toolbar, and now I will do a hard reset. Okay, so now we're back here. Let's do shift and run stop. Okay, I've cut to it fully loaded and copied over onto the RAM disk, the compiler and the editor. So now what we're going to do is we're going to smart attach our source code disk, our advent.d71. Okay, we will just switch to that and make sure everything's there. So we're in the editor, so we can see Advent is there. Okay, so we're going to do a get and S Advent. Oops. Okay, so that's going to load it off of the disk. Okay, we will list it. Okay, there it all is in all its 40-column glory. Okay, so now we will hit M again and we'll just change to drive 2. Okay, and then we will do a put. So we hit P, enter, asterisk, and that'll save it on the RAM disk. Okay, and to prove that's all going to run fine off the RAM disk, we'll quit the editor, we'll go into the compiler, and we'll hit the star there, and it will load it off the RAM disk, compile it. Like so. Okay, that's complete. We don't want the statistical summary. That will link and save it. And there we go. Let's run it. Okay, here's our wonderful text adventure. Press any key to start. Fred. Hello, Fred. Press any key to quit. Right. Okay, so I think we will wrap the video up there. So we've covered how to get the environment set up in Vice, on the Commodore 128 mode, in 40-column or 80-column. If you're going to use primarily 80-column, when when you set your options up at the beginning for the Pascal editor, then I would put it in fast mode. It just makes the compiler quicker, especially bigger programs. Okay, I kept it slow so I could show you it running on both. Okay, so I've gone over Pascal a bit, the function of the the actual structure of the programs, how that works. I mean, I've only just really touched on all the things we can do in this, but that's good enough to get us going. So hopefully some of you followed along with that, and you've now got a very basic program similar to mine running on a working save disk that you can load anytime you want. Okay, well, yeah, any questions, put them in the comments below, and we'll see you on the next video.
good time.